Should be good. Okay, so Nick.
Nick Jansma from Akamai.
Skinny from Apple.
Alex Christensen from Apple.
Diego Silver.
Steven Salesforce.
Ian Cullen from Google.
Yoav Weiss, Google.
Julia Georg, Google. Max Ignard, Google.
Todd Reifstack, Microsoft.
Jim Dresser, Google.
Bert Marks, Microsoft.
Nicolas Benia, Google.
Celtian Patrici.
Benjamin Ducasnik, Mozilla.
Will Hawkins, Mozilla.
Larry Hamilton from Intel Corporation.
Andrew Gomez, Facebook.
I
for long-term China.
Where is the good?
Requires Google. Search for Google. All of it, Amazon. Trevor Darjus, Salesforce.
I'm Diego from Sosnos.
Christian from Sussex.
Adam Rice, Google.
Okay.
Awesome. Welcome, everyone. Just curious, how many people, for how many people is the first TPAC or working group? Nice, almost half. Welcome. Cool. We'll try to make it worth your while.
Okay. Okay, so in terms of logistics, we're working with the Hangouts link that is also linked from the meeting document that's remote participation link. And this is how we will also present instead of moving around with an HDMI cable that doesn't always work. But this is all fairly experimental, so bear with us. And with that, we thought we can kick off the session here with just a recap of what we did since last TPAC. So good. So the working group's mission is to provide methods to observe and improve aspects of application performance of user agent features and API. That in practice means that we work both on ways in which we can measure performance so that developers can measure their site's performance and make sure it gets better rather than worse, as well as methods to actually make them actively better. Why is mouse? That's thanks, Rick.
Thanks, Rick.
Okay, so some notable highlights from 2019's work. So we did a lot of work related to performance timeline. That's a feature that we thought was ready to ship and move to a recommendation last year, but then during last year's session discovered that there are a lot of holes that seem critical to tackle. So this year we basically plugged all those holes, added get supported entries, added type-specific parameters, performance entry registry, and also buffered flag for L3. As far as resource timing goes, also a lot of work went into revamping the buffering model and fixing a lot of things related to timing allow origin. With navigation timing, we discovered that timing allow origin that was controlling some of the entries related to the previous page didn't really make a whole lot of sense. So we replaced all those checks with same origin checks. And user timing L3 is now a thing where we have arbitrary payload as part of user timing, which is something that people have been hacking around for a while. So it's great to see that finally out there. Preload with SRI now works both spec-wise as well as shipping in Chromium. And finally, not working group work, but work that was like incubation work that was presented here multiple times is element timing and largest contentful paint. Are both things that shipped, and we're looking forward to see what data that will bring. I'm not gonna outline all the closed issues here, but we had a lot of them. So thanks all for contributing to running down the number of issues that we have open. And we have multiple specifications that are almost over the finish line towards shipping. So performance timeline moved from PR, where it was the last TPAC, moved back to working draft because we discovered that a bunch of things are missing. But now it's, I believe, ready to move back to some recommendation status. Resource timing L2 still has one or two open issues that require work, but none of that is contentious. So I believe it will be we'll be ready to move along very soon. Same goes for navigation timing L2, and HR time is a slightly more complex story, but it's basically ready to move, assuming some objections have been, we had some objections from Ping, and they were processed, and I believe it's now ready to move.
We have time on the schedule tomorrow.
Yes, but I need to talk to Philippe because I understood that Ralph won't be able to make it. And at the same time, there is no need for this session, so I just need to see with Philippe when he'll be here. Okay, as far as relevant incubations, so we already mentioned element timing and largest contentful paint. We also have event timing and first input delay as relevant incubations that were presented to the group. And yes, maybe we'll have some more by the end of the day. As far as market adoption for the features that our group is working on, it's a lot. These are all numbers from Chrome's use counters. So this is the percentage of user navigations where our APIs are being used. Those numbers are a lot. So we have a lot of usage out there, which is why this work matters.
There's maybe two that I'd call out here. One's performance observer. So a lot of the work that went in, that we did over the course of last year, that you have mentioned, is around improving ergonomics of performance observer. But even as we're iterating that, it was really great to see the adoption of that really shoot up in the last year, 100%. The other one, which is, I guess, a little bit older, we didn't do that much work in it last year, but Beacon continues to go off into the right, which is really great to see. I know that I shared some really good data when you guys rolled it out in Microsoft in terms of like decreasing the number of sync XHRs that are touching on loads. I think you said reduced it by about 50%.
Yeah, Microsoft Edge was one of the last browsers to add it, and when we did, we saw a significant decrease in the number of synchronous XHRs.
Right. So there's lots of really good work happening here. Another one that I was pleasantly surprised about is server timing, because on one hand it's a very niche sort of thing, but on the other hand it's definitely finding some really cool use cases in the industry. So I think that's another one that should.
What are the percentage mean?
This is a percent of page loads in Chrome where we observe that a feature is used. So 5% of page loads have server timing, some server timing annotation, for example, which is pretty much more than I would expect for server timing.
Just to put this in context, like there are very few new APIs getting more into this. This is really incredible. I think this group should feel really proud of how you're doing things that are really affecting the industry. Like just as someone that speaks for like Chrome web platform as a whole, this group is doing like some of the most important work. So you shall give yourself a hand of applause for this.
All right, we're done.
Yeah, let's keep the applause to the end of tomorrow. Okay, as we also had some process improvements, so we're now recording all of our meetings and posting them online. We have improved minutes as well as at least the intent is to publish them fairly soon after meetings, so that's better. And we're also hoping to have some sort of auto-scribing facilities for the videos to avoid both anchoring down people with scribing as well as having minutes that are not necessarily 100% accurate or biased towards what people heard and what people didn't hear. So we're hoping to have basically use the recordings in order to take up some auto-scribing service that will give us transcripts of every word said. And thanks for Stephen here for taking the initiative on that. And we also had a very successful, at least from my perspective, face-to-face in June. We had great participation and cross-pollination between browser folks and industry folks, a lot of great presentations, and we made significant progress on frame timing, on device classification, and beyond that, single page apps seems like the most important subject that we make progress on and need to make much more progress on in the near future. And yes, we definitely plan to have another one in 2020. We'll try to plan this one out ahead of time so that we have dates sooner rather than later.
Yeah, and actually, as maybe a meta observation, one of the big things that happens over the period of last year. Thanks, you. Sorry, it's hard to compete with that. Is we got a lot more industry participation. So folks are joining here, like the input and the feedback has been actually really, really useful to help us prioritize features. I think I actually rewatched the bulk of the face-to-face recording on the fly here. A really good input there, and I think it's already forcing us to reboot a couple of initiatives at Ringside. We've made some really good progress in SPA now. There's a bunch of other feedback in there. So that's something I'm hoping we can encourage and make it worth every once in a while to participate in 2020 as well. Cool. Yeah, and with that, we'll pat ourselves in the back. You're all awesome.
Yeah, so the agenda for today is mostly comprised of, not mostly, we basically split up the 2 days into design section and issues section, where unlike last year, where we had many, many issues to work through, this year we're in a bit of a better shape. So we just reserved half a day for issues and have more time for presentations and discussions regarding new stuff, which is always more exciting than, talking about why things are broken. So we have the full day today. We're planning to talk about event timing, isInputPending, reporting API, reserve a large slot for SPA monitoring. I'm wondering if we reserved a 1.5 hour slot for lunch, but I wonder if people are flexible on that front. Like maybe we can trim that down to an hour, and then, depending on the SPA monitoring discussion and.
I predict that we will solve it in 45 minutes and have an early lunch.
Okay. Let's do that. We'll see.
Sorry, one question. Is it possible to have the frame timing discussion fully today? Somehow?
So I think one constraint for frame timing was Noam is dialing in
From Israel.
Yeah.
And so that time slot allows him to dial in.
You were saying frame timing fully today, isn't it?
It's at the end of the day today. 4 to 5 for you? 4 to 5.
It's at the very bottom of the.
Sorry, but then say the design discussion continued. With other topics.
Yeah.
You mean is frame pending?
Oh, it's
Oh, is frame pending?
Yeah.
We can talk to Stefan and see if he can make it here. And can you?
Yeah, I'll
bring it? Thank you. So yeah, sure, we can move things around. We also, like, theoretically, the day's agenda ends at, like, we planned up until 5. We have the room till 6, so we can, like, at least last year we overflowed, so we have that possibility. But we can also move things around and maybe.
I mean, I could also ask somebody else who knows about framing to come up with.
Yeah,
We'll check it.
yeah, we'll check in with Stefan. I know that for, I think at least for one of the subject, I saw that we registered an hour and maybe only for I think for JS software filing. So maybe, yeah, we can certainly move things around. Okay. Regarding housekeeping, we have a code of conduct. I will not read all of it, but basically, treat each other with respect and don't do anything you wouldn't do in a professional setting. And yes, this is being recorded and will be published. And with that, I'm out of slides, so I think we can start the actual discussion.
Can you go back to the agenda?
Sure.
Before we get into the actual breakouts, is there anything new that you guys want to get on the agenda? This will shuffle is green pen. No, looks like okay. In that case, Nicholas, do you want to go?
Measure
That's right.
Just so you know, regarding Stefan, I guess he's not traveling, so it's really Sunday for him.
Oh, he's not.
Yeah, so I'm unsure if he will be checking chat messages on it. It's nothing you can.
Oh, yeah, that would be difficult.
Okay, so shall I start? So I'd like to talk about some ideas I have for improving event timing, which we are incubating in Chrome. And I called it measureUntil. I'm not sure if that's a good name. Some background first about what we expose in event timing. The timestamps we expose are the event timestamp of the event that's being measured. So like the hardware timestamp. Then we expose the timestamp right before we start running the event handlers. We expose the timestamp when we have finished running the event handlers. And we expose the next paint of after the event handlers have run. So that's the duration. Duration will be the difference between the next paint and the event hardware timestamp. If the duration is long, then we expose a performance event timing entry with details about the event. So the objective of this presentation is to talk about how we can make event timing useful to measure asynchronous work. So right now, some frameworks handle events asynchronously. That can happen because, for example, if they have a notion of a task themselves, then they will create a task to handle that event. So that will not happen in the event handler itself. It will happen in some task that is asynchronous to the event handler. Another objective is to prevent people from trying to polyfill the measuring of the asynchronous work, because to do that you probably just use rafts after the point in time in which you care about has been processed. And if we do not expose asynchronous work, then there's no way for the browser to know when that asynchronous work has been completed. In particular, the events that are considered long will be incorrect because the duration will be measured with respect to the synchronous work, so only the event handler work, which means that frameworks that use asynchronous work basically can't use event timing. So,
Sorry, do you have a sense for how frequent that is? Like how many events are in fact being asynchronous? Like how prevalent is this pattern?
I think some of the examples there, like if you're going to have any input that results in a network fetch or display the content, then it's going to be asynchronous. I think that in particular is extremely common. But in the fraction of input, I'm not sure.
Isn't it the case that React,
yeah, I think
like
that was
most
learned
clicks
from
in React are
React.
effectively asynchronous?
Right.
And so that means like most clicks on the web everywhere?
Yeah, that's what I'm trying to get at.
Okay, I don't know for sure. I'm not.
Yeah, we did get that feedback from React. So they said we can't use this API because even if we increase the duration of the event handler, they tried to increase it to see if they got events, they didn't get them, which means basically the task is asynchronous, so the duration was not being measured properly because the work happens in a separate context.
Right.
And aside that, then, like Tim said, example use cases, even if you're not using a framework, are when something happens that requires resource fetching, and that happens asynchronously, and you need to wait for it to meaningfully know that, oh, this is now going to be painted, what I want. So you click, fetch an image, add it to the DOM, and then there you say, okay, now I want the next paint after that, because that's when the event is processed. Another one would be if you drag a video slider, you have to buffer the video for the new part of the video that wants to be displayed. And after that's fetched and done, then you can query the next paint to know when you're going to start playing the video again. Another one, enter a query, send the query to the server, and once the server has completed its response, then you know that the next paint should be when you are displaying the results. So the API shape looks a little weird, so I'll explain. We have basically a new method, measureUntil, which receives a promise and string. And we have a new attribute in performance event timing, which is a map of strings to timestamps. So the idea is that when an event is dispatched, we wait for its promises to be resolved. So for each call to measureUntil, you have a promise. You wait for the next paint after the promise has been resolved, and that gives you some timestamp. And you add the timestamp to the map, with the key being the name of the promise name that was passed to measureUntil. This can cause conflicts if you pass the same name multiple times to measureUntil. So I propose you just resolve collisions by overriding. So if you call measureUntil for the same event with the same promise name, then you forget about the previous promise. So now you have a bunch of measureUntils, and you have strings mapping to the timestamp of the paints. That will create the map async durations, which will be exposed in the performance event timing entry. And for duration, which is the value that we use to determine whether the event is long or not, then I just propose we use the longest of all the durations that were computed in async durations. So the largest timestamp in async durations.
Question, is it timestamp? Your duration can't be timestamp, it's something else. Duration is you have start point and end point, so what is the duration, what?
Yeah, so duration right now is the delta between the next paint and the hardware timestamp. So here, similarly, all of these durations will be also deltas. There will be deltas between the next paint of the promise and the hardware timestamp of the event.
I think we can't actually use the next paint for security reasons. I think we only get the next paint for the longest, or last promise to resolve. Because otherwise you can just register a whole bunch of promises and then know the timestamp of every paint.
Yeah, there's certainly a security problem there. I'm not sure though if just having the last one of the next paint would be fully useful. But you're right, that if it could be a security problem if in your event handler you just register a bunch of promises, like a lot of them. And then anytime you want the next paint, you just resolve the promise. However, notice that you only get the entry at the end. So you still have to wait for all the promises to be resolved. But yeah, certainly that's a security concern that needs to be considered. We would need to.
That security concern is due to listed links or something else?
Yeah, the usual suspects. So if you can measure how long it takes any arbitrary frame to render, then you've got basically text and.
Yeah. Okay.
And we said it's okay for event timing because we only pay attention to events that took greater than 50 milliseconds. But if you can register arbitrary promises, then you can get any framing if you want. But I agree with Nicholas. I think we can definitely find a solution to that problem.
Yeah, so if it may be throttling the amount of promises you can have, or it may be simply just using one next paint per event, but it's unclear what would be the right solution here. The reason we have the map here instead of simply just one measureUntil is because there could be multiple third-party vendors, for example, having their own handlers, and we don't want them to affect too much the measurement of each other, if that makes sense, because otherwise then you get your async duration, you have no idea what it means, right? So in order to make it more actionable, we do have a string associated with each promise, so that you can know what each timestamp is referring to.
But is that presumes that the vendor instruments the event, right? With event timing, you can just sit there and passively observe long events, but here you also have to intercept the event.
We anticipate frameworks annotating the events and then analytics providers picking up those annotations.
Right.
Yeah, so this async durations should only be used when you have important work going on,
right,
which implies event handlers.
Yeah, I'm just thinking out loud about your comment that multiple vendors instrumenting, and that seems less likely given the invasive nature of the actors.
Yeah.
Maybe.
It's like you could have. Yeah, frameworks plus third parties all have their own events.
There are even cases where a single party would want to look at multiple timestamps for event being processed. For example, you click on a button and you want to measure the time until the button goes to pressed, and then you also want to look until you fetch some more context.
Yeah, sure. Does this affect event timing today? So right now, if I understand correctly, you would expose a new attribute on event timing, which is a map.
It would also affect the duration attribute of the
event timing. Oh, I see. So this would.
For events that were annotated.
right. So for in the world right now, it wouldn't affect anything, but for events that are annotated, it would affect the duration. Because that's one of the main goals is to actually enable the browser to know these are the long events, right? And for that, we need to change the duration when asynchronous work happens. So this is a sample code. It may have compiling errors. Sorry about that. And this is an example where you load an image once you click. So the image to image element, and once that's done, then we solve the promise. So on the event handler, you would call event.measureUntil and then call load image, and the promise name for this is image. Does that make sense?
Usually in basic, right, like you have to wrap all your work with this stuff. Interesting in terms of getting adoption. Always a little bit powerful. That's a good question.
I think there's two questions. There's how easy is it to wrap existing work that isn't already done using promises? And what fraction of the work is done with promises today?
Right.
Certainly if you're already using promises, then it's trivial.
Yeah, I'm open to suggestions for better ergonomics, but
So this doesn't feel like event timing, this is more like user task timing. So should this be a separate API rather than adding something to the event? Because this is really not about event anymore. This is about the whole task that user just initiates.
right, good question. It certainly could be caused by other things. The problem here is, again, the security concerns of just exposing next paint, which is really what we are exposing here. We want to do it in only certain scenarios where it's meaningful for the developer to know the next paint, because we can't just expose next paint anymore.
Will this work from JavaScript triggered events? Or, okay.
No.
Wait, hold on, but like you can indefinitely keep the events and always measure until, right? I mean, you can just all at the arbitrary point you can pull up measure until.
We would, let's say when the handlers have finished running, we stop caring about further calls to measure.
But you can keep adding it.
Yeah, so you're right. You could measure until and then resolve that promise at an arbitrary point in time.
Right.
Which means you can measure an arbitrary frame's next paint time.
Right. I mean, all you need to do is just keep calling measure until.
Right, and that's where Nicholas and I were discussing earlier. I think you can expose next paint for every promise. I think you would maybe take when the last promise is resolved, look at the next paint after that. We need to think through the security implications of that a little bit more carefully. Does that make sense?
I don't like, because I mean, are we exposing different timing other than what the request animation frame will reveal?
We are in this case, yeah.
Okay, that would be problematic. What's the timing?
For us, it's our best estimate of when pixels hit the screen. And we said this is okay for event timing because we have that throttled to only handle cases where it's longer than 50 milliseconds.
Yeah, I don't think this API would be okay with that, right? I mean, clearly you can just harness the mouse moves of users in like continuously, and then for every single event you receive, you just arbitrarily schedule measure until for every like.
And
just
doesn't work with mouse moves.
It should. Why would not work? There's no restriction about this API, right?
Yeah.
Mouse move is listed.
Mouse move is listed.
Yeah.
Oh, okay, then it does, yeah.
Yeah, so I think, very good point. I think worst case, we cannot expose a particularly accurate paint time. We'll have to fall back to basically what Raph would give you. I wanted to call back just for a moment to the comment about should this be part of user timing? If I'm a web developer and I want to reason holistically about how long do click event handlers on my site take, I want to be able to instrument both click events that are handled by the browser, I'm just clicking on a link, and events which are handled by JavaScript using the same analytics, so I can look at percentiles across all of those. And in order to get both of those cases serviced in the same API, so I can use statistics on them, I think it needs to be tied into event timing.
But it's about user task, it's not about event timing, it's not about event itself. The task can be started by something else. That's why it might be better to have some generic API which can be used in several different.
But that can't solve the use case of give me statistics on how long it takes for my page to process classes.
So I had exact same thought as you did. And I think the one way to solve that is user timing to be able to associate particular user timing entry with an event, right? If we had that, then people just get.
I mean, you can already add metadata to user timing, right?
Yeah, for three.
Yeah, you can add the event. Yeah.
Well, but I'm saying event could be an explicit thing browser exposes, right? If
Yeah.
we did that, then browser can read them.
So if we do that, and I'm wanting to look at statistics about all click event handlers, that means I'm now listening both to event timing and user timing, and then combining my user timing data with associated events of type click with my event timing data.
But that's a sort of economic issue that could be very easy to solve. For example, we can add up, some getters on the performance that would give me entries associated with this, right? I mean, there are so many ways to solve this.
Yeah, I think that there probably are ways we could frame the API that way. It's not clear to me that they're easier to use or what the advantages would be.
I mean, the clear advantage will be that there might be cases where, like Oli pointed out, that maybe user scripts wants to measure the timing, right?
Sure. So I think independent of this, there's an argument that performance.mark and performance.measure could maybe use an API that is promise-based like this because it might be a little bit simpler. I think that would be pretty trivial to polyfill today, but we could add a little bit of sugar to make.
But not just the promise bit, but also the next paint bit. If we do conclude that it's secure to expose that,
or we come up with
then
something
you can have like a user timing, measure this until measure what's the next paint from this point. You could think of that as a generic extension to user timing that then we tie into event timing, somehow, rather than just have it be an integral part of event timing.
Yeah, the key thing that I want is a single place that analytics providers need to look to get the performance of event handling.
Sure.
In particular, you got to decompose the different actors here, right? You've got framework authors, you've got analytics providers, and you got end web developers, right? And so we need a standard so that when we look and we say, hey, lots of React sites have bad input latency, right? And so we go but we can't reason about it. So we go to React team and say, add this, right? It can't just be user timing because the person that owns the application is different. It's a different code base from the person that can do the instrumentation, which is a different code base again from the analytics provider, right? So that's why you need it's a coordination problem, I think, between these three different code bases.
Sure.
So it's got to be a higher level abstraction.
Sure, but as an analytics provider, how do you know what each one of those promises mean? Yeah. You can measure the whole duration, but you don't have insights into what the different events.
Yeah, and the way I envision that working would be, you can imagine React has a consistently identifiable keyword that they use there, and so as an analytics provider, you could say, here you can look at all of the timestamps that React provided you.
Yeah. Or just expose the names and then have people know, they know what their framework means.
But that naming question is completely independent of whether this map needs to be part event timing object or could be just the user timing that exists that related to the event timing, right? That doesn't completely open the issue.
Yeah, and I can see a way where we have an independent, like this is part of user timing, but we can pipe it into events in a way that impacts the event timing duration
Yeah.
or.
I think that would be completely reasonable. I think that's an
Or
economics question.
you have access to the duration somehow
Right.
through that.
I just wonder what are examples of cases where you want the next page, but there's no events happening?
You have an image gallery thing that scrolls every, like changes an image every 2 minutes. You wanna measure how long it took for the image to change. I don't know.
So the proposal here, if I understand correctly, is we added something to user timing L3, lets you say, here is my associated event with this measure, I guess. If that event is present, we will also surface this in the event timing API. But this means that if you want to do similar things and you don't have an event, you can use this strategy.
We also have the SPA discussion, which I think will venture into the space as well.
Yeah.
Because I think once we generalize it, it'll feel very similar.
Yep.
It would be nice if we could solve two things. But as I said, we'll solve this in 45 minutes and have to
It definitely feels worth writing out the proposal and what that would look like.
I have a question about the durations part of the proposal too. So like if I'm interested in the first input delay specifically or something like that, and these event handlers are also adding async fetch for an image and stuff. If I just wanted the first input delay, like the responsiveness of the synchronous code that ran on the first input delay.
Right, so you would still get the processing start timestamp. So the first input delay is defined as
Okay.
processing start minus the start time. So
Okay.
you can still get that, right?
And then you would also have async durations for all those things
Right.
as well, and then maybe some undefined time when other things were running in between those slices as well, and that would be the total duration, potentially something like that. But it could delay the delivery of the event timing until all
Yeah,
of them are
that,
complete.
there's a problem.
Yeah, I guess one of the concerns might be, if that takes a long time, if there's a very long
Then
image
you
fetch,
can
that I would
lose a lot
never
of
get.
data.
Yeah.
That's true.
Um,
Yeah, that's definitely one important concern, so.
I mean, even similarly, like if I'm only interested in just click timestamps or click processing on the page just to measure responsiveness at all, they're all kind of, could be delayed by other unassociated async tasks before they got delivered to the observer or timeline.
Sorry, I didn't quite follow that. So if you have a click event,
Let's say I was-
does use measure until or does not use measure?
Yeah, let's say I'm interested in just measuring the overall click responsiveness on the page.
Yeah.
Any other frameworks or the app itself that are also measuring or hooking into the click timestamp and doing async work. I'm not actually, as an analytics provider, I'm
Yeah.
not getting notified of those until.
Yeah. Or in the worst case, you have some rogue script on your page that is just adding event.measure until and then never resolving the promises
You
you
could actually be, yeah.
Right.
Stop it from being able to. Yeah, okay.
Can event measure until be called asynchronously? Same way that wait until can be called asynchronously. Service worker.
Like outside of, okay.
So what you're saying is if you hold on to the event object and then like post the event object to a task and then call event.measure until.
Yeah, like you have more information later and I wanna keep waiting.
So that's not gonna work because we could have already surfaced the performance entry by the time you get around to calling measure until on your event.
Yeah, so that would be an argument for doing the user timing approach instead. If you want to enable more arbitrary
That's
tasks
one of
like
the
that.
key features of user setting.
Right. Yeah, but like you can already do user timing. The question is the next thing. Do we want to enable this arbitrarily or not, right? So.
And I guess and the question there is just the precision of, do we just expose a RAF timestamp or something more precise than that? And
Is the paint a strict requirement? Could that be relied on?
I think that's the only thing we could do. I think we would still be able to say that if you have a synchronously handled case, we can expose the proper paint timestamp, but if not, we would have to rely on the.
So could you remind us why paint time is important?
So this is the case where, say you have a click and then you insert an image but then you have a composited effect on your image that takes 200 milliseconds. Like you have a big fancy blur. Or you just have too many layers on your page. We do see many cases where pages are slow.
Okay, did we already give a feedback that such is not measurable in certain operating systems?
I think the way the spec words it is like the browser should do their best to approximate when pixels have hit the screen, which is rather ambiguous.
Do you have data on what that histogram looks like of the differences relative to normal input latency? My intuition is that the compositing costs would be dwarfed by the normal input latency handling costs, and that we might get something that tends to correlate very well by ignoring that problem.
I don't have hard data off the top of my head, but we have certainly seen examples. Pinterest at one point in Chrome was seeing compositing costs that were far, far higher than any main thread costs. So we certainly do see cases where this is a real problem. It's also possible that depending on different architectures, maybe compositing costs will be less of an issue in some browsers, but.
Yeah.
Yeah,
I
what
wonder
do we
if
see?
that, like, we also have the frame timing discussion, and that kind of ties into that as well.
So it feels like we are going to need a broader conversation about like what can we do with paint timestamps. Some of that I think we should get more data on what we're actually seeing in Chrome for kind of compositing versus main thread time.
I can believe that composing time might be an issue in some cases, but I think in vast majority of cases they don't matter, and I think if we use a rough timing or timing around that, they'll be secure, right? Yeah, they'll probably solve the 80-90% of cases.
Yeah.
And that's something I think all browsers can implement in the sense that all the browsers has roughly implemented.
Yeah. That's my intuition as well. Like allowing applications to do the asynchronous measurement is like 80% of the value.
I think one particular case, scrolling, is a strong one where the compositing time is often why you don't end up getting smooth scroll, at least in Chrome's implementation. And one of the use cases I was really hoping we could solve with event timing is scroll jank. However, I think these worlds could work together where if you just do have, unless you use measureUntil, you can still get the high quality paint timestamp. If you're using measureUntil, we fall back to the lower one. The asynchronous case is also you're likely to have a larger time other than compositing, so compositing should be a smaller fraction. Right. So that's probably fine.
We've seen at Microsoft that there are specific high hit properties that we've seen in the past, and it's been a few years, where compositing was a significant portion of the time. So I would be cautious to quote any numbers. And even if we do find the numbers, if there's a top 30 site that is heavily impacted by it, it's still a big deal. So I would let data guide us on how big of an impact the compositor time is rather than.
So slightly related, and we don't have it on the agenda, but maybe we should have. It's like killing visited. Can we do that?
Power to do that?
Yeah, we can, I don't know. We'll see if it fits. But I think it's really, yeah, I think that dancing around visited has been plaguing us for.
Even if you get rid of visited, we still have all kinds of problems with cross-origin, same process iframes.
Origin same process, is that still a thing?
For many browsers it is, for Chrome and Android it is.
Firefox with progress, like there is, we will keep vision which is the most first thing like next to that. So.
Okay.
But again, not on Android.
Yeah, similar.
Go Android.
Good.
Yeah, I'm certainly unconvinced that just getting rid of visited would magically solve all of our problems.
Okay, yeah. You can still kill it.
Just for clarity, when you say killing visited, you mean cross-origin visited or?
Cross-origin visited.
And if you get rid of cross-origin visited, all cross-origin iframes, and then every cross-origin system, so then maybe you would have a case.
Okay, so compose, there's one origin.
Okay.
All right, thanks, Nicholas.
Yeah, thank you. And the next one is isInputPending. Nate and Nick, do you have slides? Like you didn't.
I have like a handful of slides that.
But can you link them to the agenda?
While we're getting the slides up, we called out React a few times. Just want to call out that we're not picking on React. They're all equal offenders. I will try the last one. If anyone wants to take this one.
Yeah, I can do that.
Thank you. Oh, okay. What was it right in the future?
Yeah.
Is the plan that you present or is Nate presenting?
I don't think Nate is presenting. Okay.
Yeah, I'm trying to share it.
So Nate, in the doc, the agenda doc open, there's a link for the hangout. That you can just dial in and present it there.
Remote participation, it's called.
Yeah, it's remote participation link.
There, yeah, got it.
Also.
There we go.
Okay.
There you go. Cool. So this is pending. I just have a few slides. I figure I'd give kind of a quick update about what it is, where we are, how testing is going, things like that. So a quick refresher about isInputPending. The idea behind this spec is basically that it lets you check, is there something? The idea being that there's a lot of overhead when you're like doing a chunk of work in terms of every time you yield to the browser, getting control back can take its own time. So sites that do like big blocks of work are generally incentivized to not break it up a ton because there's this trade-off, right? If you break up work like into this many little blocks, you end up with like time in between each block. And if you have like 10 blocks, maybe the time's inevitable, but let's say you have like a few hundred, maybe a few thousand like little blocks of work. The time in between each block of yielding to the browser and getting control back, that really adds up and that can slow down a site quite a bit overall. So you end up trading off, you make your site more interactive by breaking up the work a bunch, and you can like have events get dispatched quicker and make like that part a better user experience. But if the user just wants the site to load, that's a worse user experience now because you've made the site overall load a lot slower. So there's a bit of a tension there right now. So the idea behind this API is that we can try to get rid of that tension. Basically allow sites to have longer chunks of work so they don't have the extra latency introduced by like breaking up work even more. But still, if there is an input event, check that there is an input event and go back and like let the browser dispatch that. Maybe reorder how you're doing work so you can respond to the input event quicker. Like I said, so the API basically navigator scheduling that is pending tells you if there is an input pending. You can pass it types of input, or you can pass it, which will tell you if like any of the things you passed in, if they're pending, or you can pass in nothing, which will tell you if there's anything pending. And basically, if there's something pending, you can yield back to the browser, let the event get dispatched, and change what you're going to do otherwise. So the current status, so there's a draft specification in the WICG GitHub. It's been in origin trial in Chrome desktop since Chrome 74, and there's still some work to push up on Chrome mobile. So I don't know if Andrew or Tim wants to quickly talk about the people on the spot.
Yeah, sure. So yeah, the current Chrome implementation requires site isolation, which obviously isn't really viable if you want to ship this on all platforms. So we've been going back to the drawing board, trying to plan out ways that we can leverage like compositor hit testing, which is present on most UAs, to get this to a state where we can do per frame, per origin isolation. And so far, things are going well on that front. Hopefully we're gonna get that in the next Chrome release or the release after to determine like how viable it will be.
So to talk about like our experience with using the API so far, so like I said, it's been an origin trial in Chrome, so we've tested it out on Facebook. So the thing we tested was a very naive implementation, not full scheduling. All we did is basically the framework that loads the site. Inside of that framework, if we saw that we would check isInputPending, basically anytime that framework was deciding if it was going to load more. And if there was, it would stop, let the event get dispatched, kind of do the first round, like maybe displaying UI. But generally events on our site require like fetching new data and fetching things. So that part wouldn't get reordered. That would still kind of go to the end of the queue, but it would still like stop and do the initial response to the events quicker. That's because we're not fully rolled out on the new Facebook.com yet. The new Facebook.com has kind of full scheduling, but be able to take advantage of like doing actual reordering with this InputPending, but it's not kind of at the scale to get like valuable Earth data on like a tiny origin trial yet. So we tested it on the current site. But anyway, so the results look great. Basically, like we're able to see there's an event pending. We're able to reduce event queue time, so that's the time from like when some browsers record basically like the higher timestamp as when the OS gets the event. So the kind of the event queue time gets reduced by a noticeable amount very consistently. So that was basically exactly what we wanted to see. So taking that, when we combine that with reordering, it should basically give us what we want here. So that's looking really promising. And that's picture slides.
Yeah, so I think our experience could probably be summarized as ditto with a lot of what Nate was saying. So, but I can just kind of go over some of the results. So we have Boomerang, which is the analytics library, run thousands of sites. We have a priority to not get in the way of what we're measuring. So we put a lot of time and energy in trying to minimize our impact. And so we kind of wanted to use isInputPending for two ways. One is to get a sense of how often we are potentially impacting the user experience, i.e. when we're doing work, is there input pending that we should be getting out of the way of? And then based on kind of that assessment, potentially taking some active changes, just like Facebook was talking about, to exit out of whatever chunk of work that we're doing and queue it up for later at some other point. So the Boomerang code is often running at some pretty critical page transitions. We're running code when we start up, we're running code at onload to measure things, we're running code when the next HR finishes to measure that as well. And those are probably often key places where the user may be trying to interact as well. So we have a lot of places where we're running distinct tasks in order, and we instrumented our library just on 2 sites because it's an origin trail, so it's a little bit of a pain for us to implement this broadly at this point, but just to kind of experiment a little bit. And we basically just measured throughout all these tasks when they're executing, how frequently was there an input pending, and how long was it from the point that we detected an input pending was until we actually finished the entire length of tasks that we were executing. Gathered a bunch of data over a couple weeks, and so far it's been very enlightening for us. The median amount of time that we were delaying the browser being able to process input was only about 1 millisecond over all of the different events that we were looking at. But breaking it down into specific events like the onload event or the visibility change event, there were some cases where the median was up to 25, 40 milliseconds. So that's kind of giving us the opportunity to focus our work on what specific event handlers we're looking at, and we're doing work, which ones should we be optimizing more, breaking up, or deferring until the user is done interacting. Because a lot of our analytics, we're not presenting anything on the page. We're trying to get out of the way, we're just trying to measure stuff. So we prefer to just do work later as long as the user is trying to do stuff. So yeah, so it's been pretty insightful for us, just from a holistic how are we doing kind of point of view. And we definitely would like to keep this, if it becomes not an origin trial, to keep it in our analytics script just as a general feedback mechanism for ourselves. And then it will take a little, based on the results, it will probably take a little bit of work on our end to actually efficiently break up these tasks in a meaningful way. But we're considering planning on using isInputPending to do that work as well. So, because again, we would like to get all of our stuff at as quickly as possible if nothing else is happening, but we want to get out of the way if there is input. So yeah, overall positive. We'd like to use it everywhere.
Wasn't actually expecting that use of isInputPending. Like, I feel like you're kind of using it to get attribution that ideally event timing would give you, but it doesn't.
Yeah. So we're like for event timing, we're listening for the onload event. We're listening for other custom random things that happen, like the XHR loaded or the onload event, or when our single page app navigation calculations declare something's done. That's when we're executing a bunch of code to look back in time, compress resource timing, all that kind of stuff. And, so it's kind of not just pure user input based measurements of when we're executing code. Yeah. That's all.
I have a question here for the support event types and to click and how it's implemented in Chromium. Where, at least in Chromium, also based on the standards, whether we send a click or not depends on how the previous handlers, like JavaScript handlers, handle, let's say, mouse down or bring pointer down and whatnot events. And if they say remove normal elements, then click will not be managed at that time. So basic question is how we chose these set of support event types and whether click was something that we were looking for particularly, and why not just more raw events like down and up events? What was the reason behind that?
So we kind of intentionally left it like somewhat vague in the spec. Like, so basically the spec lets you like, the wording is like, the browser can basically customize what event types are supported, and there's an API also for checking like, is this event type supported? So the browsers can implement things differently. The other thing is like, the wording is like, if it might, like dispatch an event. So like, we figured that like, and browsers might want to lie too. Like browsers might want to just say like, hey, like, just randomly return true sometimes for different like security reasons or other things like that. So I think the thinking is like, it's like somewhat best effort. Like if the browser thinks it should return true, it can return true basically for different reasons. But if the browser thinks there might be a click, that could be a reason to return true.
I think the only situation which that's very concerning is if there's a use case where someone would actually want to depend on a click event being fired versus maybe like we want to do work in advance of a click event.
For the current implementation, I think we just assume that no events are going to get prevented, and then just see if there's a mouse down and a mouse up in the queue, then we can say that's probably a click on.
Yeah.
A question about how this relates or interacts with first input delay. So presumably if you're doing isInputPending, you could have very long tasks, but you're still doing the right thing. You're not actually blocking input. I don't see it in the spec, but is there like a plan to ignore this and first input delay or other methods?
So
What do you mean?
I mean, just not considered as a bad long task. Or I guess.
Oh, you mean for
Sorry, maybe I'm thinking long task API instead of first input delay.
So one option here would be to assume that anyone who is querying isInputPending would be a perfect citizen. And if they saw input pending, they would exit out of their task immediately. And so long tasks should then only look at tasks like put up by input pending. I think it's very difficult to reason about that until we can actually see how usage of isInputPending happens in the wild. But that's totally something we should dig into.
Yeah, I still wonder if it's reasonable to use isInputPending to trigger long task stuff. I'm not sure that's.
I mean, you're still blocking rendering for one thing, but, and there are also cases where people will be using isInputPending for use cases like next, where they're not going to yield. So I don't think we probably can't just do the kind of simple thing that I proposed, but we should look into doing something in that space, I think.
Yes, back to the supported event types. I think it's still so super vague that we can't have multiple compatible implementations because of it being so. And it's even referring to basically any UI event. Well, that's actually the interface, so you can't have UI events. You need to have something else there in this way. But it's so vague that if we would implement this, we would need to basically look at Chromium source code to have anything even close to compatible. So that's why I think we need something more precise at this point.
So the isInputPending spec?
Yeah, so it's because
It's too vague.
it's so vague, support event type handling is so vague. It's impossible by looking at the spec.
So the spec, I'm glancing at the supported event type section right now, and it said it must include click, key down, and wheel. Is that vague? I'm just trying to understand what
Click handling is very vague. It's like, because click is not user input as such, because it's based on mouse down or mouse up, basically. And then the supported types may include any UI event. Well, UI event is interface, so it doesn't.
So we run into a fundamental problem here when trying to specify it that I think you might have mentioned in the past, where it's like we can't read or like simulate what's currently in the event queue or what JavaScript will run before the event gets dispatched. So doing things like precise frame attribution makes it pretty tricky. So we can never really guarantee that if isInputPending returns true, like an event will actually be dispatched for it. It really has to be best effort no matter what. That being said, would making perhaps closer to hardware key events work better from an implementability perspective from your end, or?
Yeah, closer, what Navid said, I think closer to mouse down, mouse up For example, when.
Yeah.
That would be
I
better.
think that seems reasonable.
Yeah.
Or would it also be fair to say mapping directly to the HTML5 spec definitions for the events and the points at which that spec definition defines the events? Is that a way to,
The whole
that's better.
analysis is how user inputs actually get to the browser, that's not defined anywhere, so.
Yeah, that's the
Right.
problem, that's the problem I
Yeah.
with this, is like, there's
Okay.
not really like a place where like individual UI events are really spec well. So there wasn't a great thing to reference. Yeah, I mean, like, we could potentially look at like expanding like changing click to like mouse up and mouse down, and then expanding the list of like must support types.
And I'd like to get rid of may here, that's so vague.
Well, so May is,
Especially because it refers to UI event, which is nothing,
yeah,
it's interface.
well, specifically UI event, or just like the
It
basic.
refers to interfaces which, yeah, I don't know what spec means.
Okay, yeah, that part, I mean, we can do that.
Do you think there's a small set of supported event types that give us the vast majority of the utility? Like, could we just have a concrete list of 5 and that would give us 80% of the
The
value?
primary concern were for things like mouse move that would be like incredibly noisy and you might not care about responding to those as quickly. It would be interesting to gather perhaps like use counter data to figure out like what event types people are actually listening for and make a decision based on that.
So that may include the UI events, which is even any event, other event types. Did you have any particular use case in mind that you included them in the first place? Like
It was primarily to avoid mouse move.
avoid, no, you mentioned that it might include that. So you would assume that there are some other events that some people might be interested in that they might be adding information for. Well, what were those events?
Oh, I'm sorry, I thought you were referring to the fact that it was.
Because already was saying that let's get rid of that main, right? First of all, that main says main include UI events. UI events is just interface, not an event type. That aside, was there any reason that we say may include other event types that we haven't listed here? So what were those other event types? Do we just say, let's just not include anything from right off the bat, and then we'll stick to this list. So then see how it goes with noise expand.
I think that sounds reasonable. It was mostly just forward looking.
Yeah, that was kind of the idea, is like, there's no event that gets introduced. Like ideally, browsers should be able to make it compatible with isInputPending like right away. I think especially if it gets like kind of like integrated into a lot of scheduling and people like come to rely on it to some extent, like you want it to be able to like support like new event types. I think that was kind of the thinking there. So I think there needs to be some mechanism for that.
It might still look better just to have adapt and like change this list as we go if those events happen to come up.
And because the other problem is if you just allow anything, I think it might make it easier to misuse the API, right? Because you don't want people to just query isInputPending for events that are not really important and then be like, okay, that's fine, and then let's keep going. And then you'll have a worse experience. So you'll justify it by saying, well, isInputPending returned false, so we just keep going, right? So I think we have to be careful with which events we do support.
So you're worried about somebody introducing a new event that just fires all the time, and then somebody might accidentally query for that event, like they're just querying blindly for all.
Right.
I mean, the one potential solution there would be the wildcard not including all of the event types. So if you don't specify an event type, then we list these are the event types that will be queried for in that case.
So like a feedback.
Yeah, but just I wonder if once you is event pending, next thing was is rendering pending, or like is whatever pending API.
If you look at the schedule for tomorrow, is spring pending, is in fact on.
And we
are not able to move that to today because Stefan is on the road.
Okay, yeah,
He's coming here tomorrow? Or?
I believe that's the case.
Yeah.
Do you think if we do end up talking about that API, do you think that this is like a bad sign that we have multiple similar looking APIs, or?
I mean, it's kind of weird though, right? Because then I mean, maybe 2 is okay, but if you had like 5 things to check, right, it gets kind of ridiculous. Like, is input pending? Is rendering pending? Is whatever pending, right? It's just like keep check. That just becomes a really awkward, like, thing to do in your code.
Whatever happened to should yield?
It became this.
It became this.
Yeah.
Should yield is hard to define.
Yeah, that's also partly why like some of it's still kind of vague. Is like, yeah, I agree. Like we want it to be open enough that like, different.
So like, so that one website could say, yes, a mouse move is important enough to stop, and another website could say, no, mouse move, don't care.
Exactly.
Oh.
I mean, I think if you care about mass move, you shouldn't be using.
I mean, like if this gets ingrained into like I know basically a bunch of different frameworks are planning on integrating it into like their core scheduling. So some sites using those frameworks will probably care about mouse moves the most, and like.
Yeah, right. That's the problem.
Yeah.
A touch move is maybe a better example.
Yeah. That is much better.
Also, can you catch some on the targeting of this? So you mentioned on password requirements and whatnot. So is this API only exposed to the mainframe, or like what happens to the iframe? Like,
Right. So yeah, our plans with the Chrome implementation are to use the compositor hit testing infrastructure in order to like perform frame attribution. So ideally, yes, we do want this on a per frame basis, including for subframes. Otherwise, it's a bit challenging to reason about.
so that when the subframe sees isn't depending the outer frame cross-version or not, doesn't necessarily see that.
Correct.
As second.
There is an argument to be made, however, that anything that shares like a event loop should in fact know when is a pending. So yeah, that's actually a worthwhile topic of discussion if anyone feels strongly about that. We decided to go for a per document basis. Again, just because it was easy to reason about and met like the use cases that we saw. But yeah.
But just to be clear, does that mean you're doing hit testing when you call isInputPending something?
It happens really when you
So if I understand correctly, there could be input pending that hasn't yet reached the hit detection, and it will only become as input pending at the point that the hit detection attributes it to a document, to a frame, which then will be mapped to a document. Yes. And that at that point then is when, okay, yeah. So just thinking conceptually, it does seem reasonable that same event loop would, if the purpose is to allow work to get out of the way, that same event loop would want access to the isInput pending. I have not considered whether it should be able, whether it, yeah, right. So if I only put on my performance hat, not my security hat, we want
You
it.
could figure out a way, same event loop, but still filtering out cross origin, like input events, then that would be absolutely wild. But for now, we do want to make sure we don't intercept cross origin events a lot.
Yeah.
Right.
Correct.
And one more question. In the world that we have like perfect testing in CC, cool, that works fine, although it might still suffer from some basic conditions, but that aside, I don't care about that at this point. What happens in the cases that right now we don't have that information? Like some cases that CC does not know that's perfect target. What do we do? Which frames do we attribute this dependent to? The main frame? Is it just best case of CC?
Right, so this is still like TBD. I think there's an experiment going around to separate, to basically force layerize cross-origin frames to deal with this.
I think worst case,
This,
we probably do want to let the browser just say like, I can't reliably tell which frame this is associated with, so I'm not gonna tell anyone this input exists.
Anyone else, that's default.
I think that would be the.
Which could be problematic, because then you run more scripts blocking the input, right? I guess there's not a better solution.
And we would certainly, if we do end up with an implementation that has that property, we would want to be measuring how often we run into that case.
So yeah, the two main things to be concerned about are focus and frame movement itself. It makes sense to, like, when a subframe is being moved, to perhaps like hamstring this API a little bit, for security reasons and attribution purposes. Focus is a little bit more common. Yeah.
In terms of the Chrome implementation, I'm not sure where you're exactly with, is it CC or is it browser, but there's another event queue, to your point, in browser and this, that also queues the events and hit test them.
Yes, that's what we're currently using.
That's where so then in that scenario, there's a scenario called asynchronous hit testing, because we don't have information there, and that hits the main thread of the render to get the.
Only when when it fails.
I see. So you handle that case as well.
Yes.
Yes, should we move on to the next topic?
Yeah, looks like, we are waiting for,
We're a little bit
Anna.
ahead of schedule, yeah, we have uninterrupted, hopefully 10 minutes, so.
yeah,
Or should we get the break?
We could, yeah, we could break this down.
yeah.
Starts, yeah. Should do that. Instead. Well,
I guess the core question is, what time does the break period start? Does it start at 10?
oh,
That's what I,
Yeah,
yeah, that's important.
Yep,
Can I try pinging Jason?
Jason is, I guess it's other folks.
Yeah, Jason's doing it. But I think at the end you're gonna try it. Yeah.
Our break is from 10:30.
so,
okay, so we've just got 10 minutes. So be back in 10?
Sounds good.
All right.
Yep, cool.